So this problem asks, kind of simply, if we are observing as a bystander this rider in this thing they call Barrel of Fun, which is a carnival ride where they spin you around, you get stuck to the back of a wall, and if you're going fast enough, they can drop the floor out from underneath you and you get pinned to the wall and don't move. So they're asking, what is the free body diagram of this person? So if I were to look at the free body diagram of the person, I would know there's a couple things going on. First off, this person is being pulled towards the ground, so there's a weight force pulling down. Also, this person is moving around in a circle, and the wall is actually what's causing them to go in this circle. They want to go in a straight line, but this wall keeps pushing them inward. So there's going to be a normal force pointing in. The wall points normally outward on this person. And this normal force is what provides our centripetal acceleration. And last but not least, something has to balance the gravity force. And what actually balances the gravity force is the friction force. So this person's trying to slide down the wall, but friction is keeping them there. And it's actually kind of an interesting one. If you ever get a chance to play on this ride, if there happens to be a water ride nearby, the people who come in wet have a slightly different coefficient of friction, and sometimes their coefficient of friction is low enough where they will slide down, but only because they're wet and their coefficient of friction changes. Most of the time, people get stuck to the wall and they're fine. So it's a fun little ride, but the free body diagram has three forces: a weight force, a normal force from the wall pushing outward on it, and a friction force that points in the upward direction, keeping the weight force in check.